Let's take a look at instantaneous voltage. Now we're going to convert seconds to degrees and degrees to instantaneous voltage. So the formula for instantaneous voltage from degrees is this: instantaneous voltage is equal to V max, or the V peak, times the sine of this angle theta. Now here's a rotating magnetic field around here, creating this sine wave here, and this angle here is the degrees here. This happens to be 45 degrees. So all the sine is, when we take the sine is equal to the hypotenuse, which is this here over the opposite side here. And this opposite side, that's our instantaneous voltage, and this hypotenuse, that's our V max, or the peak voltage. If we take the hypotenuse and multiply each side by the hypotenuse, then the hypotenuse times the sine of the angle is equal to the opposite side. So all that is the V max times the sine of the angle is equal to the opposite side, which is our instantaneous voltage. So now let's take a look at 1 hertz, or 1 cycle per second. So that's equal to 360 degrees per second, once around 360 degrees every second. So 60 hertz, you're going to have 21,600 degrees per second. 60 times 360. And the period, the time of 1 cycle here, is going to be 0.016666 seconds. Okay, and that's just 1 second divided by 60 here, and that's just time here. So if we take the time times the degrees per second, then we're going to get back to 360 degrees just to check it. So we want to convert degrees to seconds. Okay, so we have 180 degrees here. That's going to be right here in the center point. So 180 divided by the degrees per second to 21,600. That comes out to 0.008333 seconds. So this time here is 0.008 seconds, and that's half of this period here, the 0.0116 seconds here. So that's right in the center there. Now we want to find the instantaneous voltage with degrees, so we take our formula up here. The V max is equal to the sine of 180. Now on our calculator, the sine of 180 is equal to 0. So our voltage is going to be 0 at this point. That's our crossing point right there, 0 crossing point. So let's take a 45 degrees, and we're going to convert that to seconds. So we take our 45 and we divide that by our 21,600, our degrees per second, and it comes out to 0.00208 seconds. And that's this time from here to here. And we take the sine of 45 degrees, and that's going to be 0.707, and 707 times the peak value here is equal to, that's our RMS value right there. So we want to find the instantaneous voltage at 0.00138 seconds. Okay, so we want to convert the seconds to degrees, so we take our seconds, 0.00183 seconds, times the degrees per second, 21,600, and that's 30 degrees. So now we have our sine of 30 is equal to 0.5, so our instantaneous voltage at that time is going to be 0.5 times the peak voltage, so it's half of the peak voltage there. Now, that's for 60 hertz, there's 21.6 degrees per millisecond on time. And the sine of 90 is equal to 1, so at 90, it's going to be our max voltage. 1 times our max voltage, so that's our max voltage. And that's all there is to the instantaneous voltage. So if you know the seconds here, you can calculate the degrees, and if you know degrees, you can calculate the V max here, or the instantaneous current. Instantaneous voltage. So that's it. Thank you.